In the last video, we saw how we can use the get-env function to get details about the environment variables that process has access to. For example, you can run a C program and access an environment variable that you just set using the command line. So there's other kinds of information that your process has access to. There's a whole bunch, and actually everything in /proc that we looked at in the previous video, those are all accessible through functions. One of them is getPID. So now let me just go back to the /proc discussion, and remember, when we go to the folder or directory associated with a process, you can cat status, and you can see the process ID of the current process and also the process ID of the parent. In this case, it was the VI program, which was running under bash, and so the parent process ID, PPID, was the process ID of the bash shell. So typically that's going to be the case, though not always. We'll see situations where the parent will be something else. So usually when our simple programs, if you were to use the getPID, you would just get the PID of the current program that you're setting up, and get parent process ID would be usually bash, but of course it can be anything. So how to use this? You need to #include a few things. Let me just double check this because it might have changed. Let me just do a man get PID, and you need to #include Csis/types and uni std. I think I might have had something different. Csis/types and uni std. Okay, so these are what you need to get these functions working. This function doesn't take any arguments and returns something of type PID, which turns out to be compatible with int. Almost always it'll be compatible with int. And usually it's always going to be positive, though whatever this returns is, I think not always, but pretty much we can be pretty safe in most of the systems that we will use. getPID will return something positive, and actually something pretty small, because the number of process IDs most systems restrict to about 32K. So they're not huge numbers. Okay, so how do you call it? You say int PID, and you can, instead of using int, you could just say PID_t or PID type. PID is equal to getPID, and then you can print it, pretend it's just a regular int. There's all kinds of other functions that you can use. You can get the priority of a process. So what is the priority? It means like how likely it is to get CPU time. So if you want high priority, or actually in Linux we think about, from the point of view of setting priority, we think of niceness. So for example, this has niceness factor of 19 and a priority of 19. Most of them will have a niceness of 0. This has a niceness of -20, which means it's not nice, and this is some time critical application that should run at a high priority, that is with a high likelihood of running on the CPU. And so you have negative niceness when you have higher priority of running on the CPU. Most of the time, a lot of things will be just 0. Okay, and then you can bump up your niceness or your priority. Most of the time, what we will do is by bumping up niceness, we're saying we're going to be nice to all the other things that are trying to run. You can find out the current priority, and you have to pass in actually right now you have to, here it is, getPID. You get the process ID, and you need that as one of the input parameters. It's the second one. I thought for a second was the first one, but it's not. And then you want to pass in what you want to get. So usually, almost always, you'll get the priority of the process. Okay, so this is always the same, and then if you know the process ID of the process you want to get the priority of, you use that number. Most of the time you don't, and so what this will do is get the PID of this program in which you have this function call, and so this whole thing will give you the priority of this program that's currently running. Okay, so niceness, when you say plus 20, you're saying you want to be nice to everyone, so you're going to run slower. If you ask for negative niceness when you set priority, that is, you want to run faster, you're not so nice to everybody else. That's how it works. So it's sometimes it's a little counterintuitive, but actually I think it should also be intuitive. When you're being nice to everybody else, and so you run at a lower priority. That is, you have less access to the CPU. Okay. There are all kinds of other limits, and you can try this command. This is ulimit, the ulimit command. Let me just try to run it, make sure we have, ulimit. Okay, so most Linux systems these days come with unlimited access, but I think if you log in to our server, you might see something different. My network connection is down, so I can't check. But you should be able to log in and see more details. If you say ulimit -8, it'll give you all kinds of things. For example, see what's a good one to look at. You can check virtual memory limits, your stack size. Oh, here it is. So if you have a program that uses a lot of recursion, be aware that the default stack size limit is 8 megabytes. And so if you think you're going to need more, if you have a really complicated program that for whatever reason needs a bigger stack than 8 megabytes, you can set the limit. Or if you want to use your program to find out what your limit is, you can do that by calling the getRLimit and ask for the stack size. And the man page will tell you what to put in here to find out what your current limit is on your stack size. Okay, so you don't have to use that. There's a whole lot of functions, but let's move on to some of the things that we will use a lot more of. So remember, every process you run has a parent. A program started from the shell and has the shell process, the bash shell, as the parent. So in this case is an example where you're logging into a remote server. The server runs the SSH daemon and you log into it, and then it runs the bash shell for you. So let's say your name is this, and you get a bash shell, and then you run vi. So the parent of vi is bash. The parent of bash is this SSH daemon. So you might ask, well, can a running C program that you wrote become a parent? That is, can a program start a child process? That is, can a program that you write be a parent to some other process? Yes, it turns out you can, and it's using this fork function. So it's a very important function. Make sure you understand this. To use fork, you need 2 pound includes, and check that, double check that. I believe this is right. I believe just like with the getPID function, it returns PID_T, which is compatible with int, and most people use int. Just assume that the value that fork returns is an int. Okay, so how do you use this? So you just declare an int and assign it the value that whatever fork returns. Almost always, even though you don't have to do this, almost always, the first thing that you do after you do a fork is to check the return value. So in this case, fork returns, and it saves the return value in this int, and then you check it. Now here is the thing that's different about fork that you've never seen before, unless you've done fork before, is that this function, although it just looks like a regular function, it returns twice. Once in the parent and once in a brand new process. It's called a child process. So we've never had a function that returns twice. This is maybe the first one for most of you. This function will return once in the parent process that the program this is in, and then what happens is fork creates an exact copy of this process and returns a different value in that new copy, which is called a child. Okay, so the way to visualize this is, let's say you have a program, myprog, and it has a process ID 4231. Somewhere in here you have a fork, you have a call to fork, you assign you save that value that fork returns into this variable p, assuming it's an int. And here in the parent, what you will get is usually, almost always, you'll get some number bigger than your current ID. So let's say myprog is running with a process ID 4231. This will return with something like 4232 or something bigger. Let's just say it's 4236. What happens after the fork is the parent process continues, keeps on executing all the statements after fork. But, that's not all that happens. When you do a fork, what happens is you create a complete copy of everything that's in this program, and it runs as a separate process. Then after that, both processes run. So this fork, what it does is create a copy of a program, runs it. How do you tell which program you're in? Well, fork returns the process ID of the new process, that is 4236, to the parent. Inside this copy, fork returns, because it's just a function call, it returns a value. And this inside the child, the process ID is, inside the child, fork returns 0, not the process ID of the child. So that's why, almost always, whenever you see a fork, the next thing that you will see is an if statement that checks. What does this return? If it's returning something other than 0, then all of the code in here is called the parent code. The parent will execute that code. In this case, it's just a comment. And if it is 0, you are going to be executing in the child. And once again, in this case, it's just a comment. So typically, to keep things straight, this is what you do. You call fork, you check the return value. If it's not equal to 0, you execute the parent code in an if block, then block, and then there'll be an else block for all the child code. And you can call functions and all of that inside these blocks. There'll be 2 different programs running after that. So you call fork once, 2 programs. Both processes run at quote-unquote the same time sliced. So if you have a single processor, they are actually sharing that processor. But these days, almost every machine that you buy has a multi-core CPU, which means that you can actually run 2 processes at exactly the same time. They are time sliced, but it's possible that they will use different cores of the same CPU. So that's possible. So it would be possible for 2 programs if you have a multi-core system to be running at the same time. So now exactly what does a fork do? If you take your process, let's say a program is called myprog, it has process ID 4231 just like before, it has all of these different areas, stack and everything. As soon as you hit a call to fork, you create a complete copy of everything in this process ID, this process with process ID 4231. You give it a new process ID, let's say it's 4236, but all of this is exactly the same. Everything is just copied over. And then the very next line of code gets executed in both the parent and the child. Okay, all of the variables that were in the parent are available in the child. Okay, so typically, once again, there's more to it, of course. Typically what you do is you call fork, you have an if statement, check if the return value of fork was not equal to 0. If it's not, then you know that you are in the parent, and so you execute parent code. And almost always what happens is you wait. And what you do is you wait for the child to finish. Okay, so you execute parent code, and then this is a good thing to do, because otherwise if the parent continues while the child is still executing, the parent might quit and might cause all kinds of problems. Now the else part is executed only by the child. So you think of it as 2 processes. One goes to executes the then part of the if statement, and then in the other process, fork returns 0, so you execute this part. So these are the kind of pictures you want in your mind as you're analyzing fork. Now, just like with recursion, this gets kind of complicated. Okay, so the best thing to do is to practice.